happens in a single heartbeat and why do you hear that lub-dub sound? That is what we are going to do now. We are going to learn about the cardiac cycle. Right? We are going to learn about the cardiac cycle. So what is a cardiac cycle? It is the sequence of events or what are the things that take place in a single heartbeat. So in a single heartbeat, blood will come into the atria, go into the ventricle, pump out the heart. So how long does it take for that? Around 0.8 seconds. So within 0.8 seconds, blood comes into your atria, all those electrical signals, everything is stimulated and it will go into the AV bundle, AV node, AV bundle, Purkinje fibers, and it will stimulate the ventricles, atria, blood from the atria will come into the ventricles. See, even I can't say it as fast as I can. I can't. Why? Because that thing happens so quickly, within 0.8 seconds, it is difficult for us to even describe. Okay. Now what happens? If you take your entire cardiac cycle, it can be divided into 3 stages. One is known as the atrial systole. The other one is known as the ventricular systole. And the other one is known as complete cardiac diastole. So this atrial systole is 0.1 seconds, this one is 0.3 seconds, and your complete cardiac diastole takes 0.4 seconds. So what happens in atrial systole, ventricular systole and complete cardiac diastole? So shall we start from complete cardiac diastole? Because that is the point where blood enters the heart. Okay? So when you take complete cardiac diastole, that is when both your atria and ventricles are completely relaxed. So systole means contracting, diastole means relaxing. So in complete cardiac diastole, you have your complete heart, your entire heart is relaxed. So that includes your atria. So over here you can see this is the atria and this is the ventricle. So your atria is also relaxed, your ventricle is also relaxed. So over here I will draw the atria and the ventricle. Okay, so over here you have the valves. So as the blood is filling into the right atrium and the left atrium, right? As blood is filling into the right atrium and the left atrium, for the right atrium is the superior vena cava and the inferior vena cava. For the left atrium it would be the pulmonary veins. Okay? So as blood is filling up inside the atrium, what can you tell about the pressure inside the atrium? It will increase. But has the atria contracted? No. Just by blood accumulating, the pressure inside the atria is high. So as the pressure is higher, so the pressure in this atria is higher than in this ventricle. Pressure in this atria is higher than in this ventricle. Then will the valves open or close? It will open. This causes blood to travel from the atria into the ventricle. Blood to travel from the atria into the ventricle. Okay? So now, during this period of 0.4 seconds, both the atria and the ventricle is relaxed. So during this time, blood is entering the atria and that blood is moving into the ventricle as well. Okay? So now this entrance of blood into the atria, eventually once these 0.4 seconds are done, it will go into the next phase known as the atrial systole. What did I say systole was? Contraction. So at this point, the atria starts contracting. Can you remember from our electrical lesson? As the atria is contracting, before the atria contracts, the electrical current should start. So what is the part that should start or fire? The SA node. Very good. So the SA node starts. So at around this point, the SA node is starting its own current. As the SA node starts its current, that SA node's, now where is SA node found? Near the superior vena cava. So as here I have the superior vena cava. Okay, let's say this is they only show the ventricle, I think. Yeah, never mind. So let's say this is where the SA node is. Okay, that SA node will start firing, sending the information to the other parts, the atria, the right atria and the left atria. So what does this cause the atria to do? Contract or relax? It causes the atria to contract. So but we saw during the complete cardiac diastole itself, blood is going from the atria to the ventricle. In atrial systole, the blood that has remained, that is still now in this 0.4 seconds, all the blood will not go into the ventricle. Some of the blood is remained. That remaining blood will go from the atria to the ventricle into atrial systole during atrial systole. I actually was fascinated by this. I thought the atria pumping the blood only will cause most of the blood to go to the ventricle. But no, 70%, this is not there in syllabus, 70% of the blood goes from the atria to the ventricle during complete cardiac diastole. Only 30% of the blood goes when the atria is contracting. Okay, so now the atria contracts, causing the remaining of the blood to go into the ventricles. Okay, remaining of the blood to go into the ventricles. So now can you remember from the SA note, blood is traveling, the electrical current is traveling all over the atria, but it does not travel directly into the ventricle, but rather it goes to which node? AV node. It goes to the AV node. Then the AV node will generate its current. As the AV node is generating its current, it will go into what? The AV bundle, then the bundle branches, and then the Purkinje fibers. Okay, so that current is eventually going into what? The ventricle. So as the current is going into the ventricle, what will it cause the ventricle to do? It will cause the ventricle to contract. Now, which stage are we coming into then? Ventricular system. So that AV node, AV bundle, bundle branches, Purkinje fibers, all of them start getting stimulated at around this point. Now, as the ventricles are starting to contract, the pressure inside the ventricle, now will it be more than the atria or less than the atria? More than the atria. But if the pressure is more than the atria, the blood that was in the ventricle can go back into the atria. But that is prevented how? Due to the presence of this atrioventricular valves and that caudate endinate which prevents the inside out turning of these valves. Okay, so as the ventricles are being contracted, the pressure inside the ventricles are increasing, but that doesn't cause the blood to go back into the atria due to the presence of these atrioventricular valves. These valves only ensure that the blood goes from atria to ventricle. However, when the ventricle is contracting, this causes the open valves like this to come together like that. Can you hear that sound? That is the lub sound that you hear. So, in your heart, you can feel lub, 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 lub. The first sound, the lub sound that you hear is this atrioventricular valves closing. Just imagine and see, this entire process is happening every time you feel the lub dub. Okay, now we are still in the lub part, now I will come to the dub part later, but the lub is due to this. Understood? As the ventricle is contracting, the valves close together. Now what happens to the blood then? Now, as the ventricle is contracting, there are two openings. One is from the atria to the ventricle and the other one is from the right ventricle to the pulmonary artery or the left ventricle to the aorta. So let me draw that as well. So this will be the part. This is not for the heart, is obviously, but just deal with it. Okay, this is the aorta. Okay, so here also you will have valves. Okay, so now as the ventricle is contracting, eventually the pressure inside the ventricle will be larger than the pressure inside the pulmonary artery. So the right ventricle pressure will eventually become higher than the pulmonary artery. Left ventricle pressure will eventually become higher than the aorta. So then what does that do to the valves? It will cause the valves to open. Then if the valves are opening, the blood that was present inside the ventricles will now move into the aorta and the pulmonary artery. Okay, so now due to the ventricles contracting, it causes these semilunar valves to open, allowing the blood to go to the pulmonary artery and the aorta. Right. Then what happens? So now during the latter part of the ventricular system, now the contraction is over. Now what happens again? Now the ventricles and the atria are relaxing. So now the ventricles and the atria are relaxing. So if the ventricle is relaxing, what happens to the pressure? Does it increase or decrease? If it is relaxing, the pressure will decrease. So the pressure inside the ventricle goes down. It eventually goes down to a point such that the aorta pressure, the pulmonary artery and the aorta, now they are accumulated with blood now. So that will exert a pressure in itself. Okay. So now this pressure will be larger than the pressure in the ventricle. So what will that happen? What will that do? That will cause the blood to go back into the ventricle. But do we want that to happen? No. Then how is that protected? By the semilunar valves. So the valves that were like this will now close. Can you hear a sound? Right. I can just do it this way. Okay. Can you hear a sound? Right. That is the dub sound. So now, heart to mail, battery, all na, all is well. You know that song? No, wait, let's see. How does it go? Heart to lay, battery, charge na, all is well. So right like that. Keep your hand near your heart and feel it. Lub, dub. So every time you are feeling a lub and a dub, lub is the closure of the atrioventricular valves, dub is the closure of the semilunar valves. Okay? Right. So then during complete cardiac diastole, both the ventricles and the atria are relaxed. So during that time, since the atria are also relaxed, the superior vena cava and the inferior vena cava and the pulmonary veins will bring blood back into the atria. There is something that many people don't really think about. That is during ventricular systole, during the latter part of ventricular systole itself, the atria is relaxing. Okay, because here the atrial systole, the atria contracts and then the atria relaxes, but at the same time ventricle contracts. Okay, so during this part itself, during ventricular systole itself, blood is going into the atria. Okay, but at that point, can it go from the atria to the ventricle? Now at ventricular systole, the atria is relaxed, so that causes blood to go into the atria. But at that point, can the blood in the atria go into the ventricle? No, why? Because the ventricle is contracting. Then the pressure inside the ventricle is high. Then the blood inside the atria can't come. Okay. So once the ventricle is relaxed, then all of a sudden this valve will open. That is when most of the blood will go into the ventricles. Okay. So the three stages are atrial systole, ventricular systole and complete cardiac diastole. So this is how you get the lub dub sound. And what happens at 0.8 seconds. So all of this, now I think maybe I took 8 to 10 minutes to explain. It takes place in 0.8 seconds. Okay, that electric current going from SA node to the AV node to the AV bundle to the bundle branches to the Purkinje fibers. Now I said it correctly. Okay, so all of that, blood going into the atria and the ventricle, all the valves closing, all of that takes place in a sequential manner in 0.8 seconds from the day that you were born to the day that you are going to die. Okay.